Okay, dear students. So in this video, we are going to do Stefan Boltzman law. There are two laws that we want to learn as per the radiations are concerned. The first one is Stefan Boltzman, and the second one is the Wien's displacement. We will see it in the next video. So Stefan Boltzman law talks about a body. First of all, such a body in higher science, it is specifically categorized as lumped system. Lumped system means that you are literally talking about a sphere, like all of the body is creating a lump of itself. So that is called lumped system. So this body has attained a capital temperature T, and this temperature is very high, and it has already attained it. We're not talking about who has heated it, how it has attained that much of the temperature. We don't care about it. And high temperature does not only mean that it must be 500 degrees centigrade or something. It could be 28 degrees centigrade also, because we are always comparing it with 0 Kelvin. So even 100 Kelvin, which is kind of a very negative temperature on a Celsius scale, even that is good to go with. Even 0 degrees centigrade, which is 273 Kelvin, even this much of the temperature is supposed to be hot body. Okay, so this is the body. Now, what Stefan Boltzmann law says, it says that the power radiated, again, I told you that in the topic of energy transfer, what are we interested in? We are interested in rate at which the energy is flowing out. Okay, even in the conduction, I told you it is dq by dt or delta q by delta t. Like what is how much of the joule they are moving per second. So the unit here is again watt, and this is written as P because you're talking about a simple body here which is placed somewhere. So this is the body, the lump system, and this P is found to be directly proportional to the fourth power of the absolute temperature. The fourth power of the absolute temperature. And this power is also directly proportional to the area of the body, as we did it in the earlier video. If I take up this condition that this is a very big body here comparatively, and the temperature of this body is also capital T. So it means that every particle which is at the surface is going to emit the same amount of energy. No, like it is emitting the same quality of energy. And here obviously there are lesser area, so there are lesser number of particles, you can say. So clearly bigger is the surface area, bigger will be the radiation. So this is directly proportional to A, the surface area. Be very careful here. This A is going to be coming, many a times, and you would be every time you will be confused. What is this area? So this area in Stefan Boltzmann law is the surface area of the radiator or the radiating body. The surface area of the radiating body, the body which is hot and radiating energy. So that is directly proportional to the area. So our formula for a black body, you can say for a black body, the power radiated will be given by, we are going to introduce a constant of proportionality because these were proportional, and whenever we have to convert this symbol into equality, we have to introduce a constant there. So in this case the constant is not k, it is sigma, Greek letter sigma. So this sigma a t raised to power 4, where sigma is called Stefan Boltzmann constant, and the value is 5.67, 10 raised by negative 8, and this is the unit. Anyways, watt per meter square, kelvins for, we no, doesn't care about this. So you can just write SI as a unit. So this is the Stefan Boltzmann law, Stefan Boltzmann constant that should be given in the data booklet. Now what next? Now what the hell is this E, and from where is this coming? So this is for the black body. What about the gray bodies? So for gray bodies, we have already defined emissivity. Emissivity is the power radiated by a gray body divided by the power radiated by the black body at the same temperature, which is given by this formula. So it will be sigma a t raised to power 4, which on arrangement will give you the same formulation that is written on your screen. P is equal to E sigma a t raised to power 4, where E is the emissivity and we know that emissivity has a range from 0 to 1. So emissivity could be 0.8, 0.9. So that will be given to you if you're talking about a gray body. For black body, E will be taken as 1. This is for the black body. So this is it for this video. This is the Boltzmann law, and there is one more thing about the Boltzmann, but that we would be doing in the next video. Okay, dear students, so this is it. This is Professor Varun. Thank you. All the best. Bye.